Right, good morning everyone, and welcome to our, probably our shortest class that we have recorded. So this won't be a full video. This is just a quick subnetting video in response to a question that I got on the group. So just for context, this is the lab that they asked about, lab 6, the subnetting lab. So I believe that will be the lab for next week, Tuesday, if I'm not mistaken. We right now on currently lab 5, but you do have the knowledge to at least start lab 6. So go ahead and try it if you want. But well, this is what the lab looks like. Basically, you need to do some of the subnetting stuff we discussed in the last class, and then you need to address hosts using addresses in these ranges. But before you do all that, you need to calculate all the subnets and the first usable host addresses and the last usables and the broadcasts, and all of this stuff is very important, of course, when you have to subnet in the real world. So I didn't want to use this exact example because I don't want anyone just copy and pasting what I did and getting the lab completed like that. I want you all to actually be able to do this because, as I said, subnetting is a very deep topic, and this is the starting point. So you need to at least understand this before you go into more deep topics. So what I did is I created my own made-up question here, and I'll be going through this question as an example, and I hope that by following along with this example you'll be able to understand the lab, and then you'll be able to go back to this site here, and you'll understand what to do for all of these questions, and then maybe even go on to here to the more advanced questions once you're comfortable with the basics, of course. So make sure you understand the basics first, and as you practice and you see the patterns, like subnetting is a big pattern based topic. Once you understand the patterns, and you could just in like 30 seconds you could fill out all of these fields and then click next and get it, well, show answers and get it correct, and click next and go on. Once you reach that point, then go on to the more advanced questions, and you'll see how much deeper we could go in subnetting. Yeah. Right, so let's see. This is the made-up question here. So as a new network administrator at CFSI supermarket, you have been asked to subnet the following block granted to you by LACNIC, which is our Trinidad and Tobago's regional internet registry. So basically they have all of our public IPv4 address space. So they have the addresses that can get you onto the internet, and they are the ones who assign it out. So your boss man at the supermarket, Shiva, has told you that each new subnet from this big block that we have been granted, each new subnet needs to accommodate 100 host machines. So he has given you that mandate, and he wants to know the following information: the maximum number of subnets that you can create from this block, the maximum number of hosts that can be addressed in each of those subnets, so how many hosts can fit in each of the new subnets that we're creating, the subnet mask in each new subnet in both notations. So remember, we have two ways of representing subnet masks, so he wants both for each new subnet, and the network address and the broadcast address of each new subnet, as well as the first usable address and the last usable address on each new subnet. So this should address these things here: the subnet address, first usable, last usable, broadcast for each new subnet. So hopefully you'll be able to understand that lab from doing this example. Oh, 1 second. Right, so hopefully it's a little bigger there and you could see it better now. But you can also follow along because this presentation should be visible to you. Presentation 3.1 in the thing. Right, so answer now. Let's begin by gathering the important information from this question. Our initial block is 170.246.165.0/24. So we initially assigned a /24 block. And we need to fit a minimum of 100 hosts in each new subnet that we create. Remember that we have 32 bits total in an IPv4 address, so this will never change. All IPv4 addresses have 32 bits in total. Our subnet mask tells us that in this block we are using 24 bits for the network portion. So that's what the slash 24 here indicates. Our number of host bits is thus 32. Total IPv4 address never changes. That 32 is very constant. Minus 24. This one will change, but this is our initial block, so they will give us this information. So 32 minus 24 is 8 host bits. So you have 8 host bits in our assigned block. So our initial block size is then 2 to the power of 8, which is equal to 256. So the block size doesn't really tell us anything useful, but it is important in calculations, which is why you'll see a lot of those exam questions and practice questions ask you about block sizes. So this is just how to calculate that block size. You take the number of host bits and you put 2 to the power of number of host bits, which is 8 in this case, which is 256. No units, just a block size 256. Now each new subnet needs to accommodate at minimum 100 hosts. So basically, you usually in real networking you want to leave some breathing room too, so that if you bring a new host machine or a new printer or whatever it is, you have space on a subnet to add new addresses to it. So we take our requirement now, and we want to make sure our subnets can at least accommodate that. So how many bits do we require to accommodate 100 hosts? Well, we could start off from 0. We could put 2 to the power 0, and then 1, and then 2, and then 3, taking more and more bits until we reach our number. I know a few values just because I've been doing it for a while. So 2 to the power 6 is 64. So for you could start off at 0 and say 0 bits would give us, well, theoretically 1. 2 to the power 0 is 1, but narrowly. So 1 bit will give us 2 to the power 1 minus 2, of course, and then 2 to the power 2, and then 2 to the power 3 until we reach 2 to the power 6, which is 64, and then 2 to the power 7, which is 128. So we see the 100 here. We know 100 going to be between 64 here and 128 here. So we know we're in the correct range here. So if we take the 6 bits, we will only get at most 64 hosts. Remember, we have to minus a 2 from this to get the number of actual usable hosts, as we mentioned in the last class. So we would actually only get 62 usable hosts here. We need at minimum 100 hosts, so we can't do 6 bits. We need to increase again to 7 bits. So you see 2 to the power 7 is 128. Even if we subtract our 2 here and we get 126, we still could fit the 100 hosts in here. So 7 bits will be fine. So we therefore need to ensure that we leave 7 bits in the host portion of our new subnet. We therefore only have 8 minus 7, which is 1 bit to subnet with. So with 1 bit, remember we had that 24 there, and we eventually realized that we had 8 host bits here. And as we said in the last class, you could only use your host bits in your initial block to subnet. So if we need 7 bits to remain in our host portion, and we only had 8 bits to start with, then 8 minus 7 gives us 1 bit to subnet with. We could only borrow 1 bit to subnet with to satisfy all the requirements. And 1 bit gives us 2 to the power of 1, which is 2 subnets from our initial block. So we could fit 2 subnets inside this big block and still satisfy this requirement for 100 hosts. Yeah, I hope you follow along with that. So as we just figured out, each block will have 7 host bits. So remember, we just calculated that we need 7 host bits to remain in the subnet. So with this 7 host bits, it means that we could accommodate 2 to the power 7 minus 2, which is 126 hosts max in each new subnet block. So with those 7 host bits, we put 2 to the power 7 and we minus 2. Always, that 2 is constant in every subnet. We minus 2 to get 126, because 2 to the power 7 is 128, and 128 minus 2 is 126. So we could fit 126 hosts max in each new subnet block. So by the way, the block size for this new subnet, for these new subnets, is just 2 to the power 7, which is 128. So remember, our initial block size was 256. So the block size in the subnets is going to be 128 after we borrow that bit. Yeah. Now to get the new subnet mask, so that's, by the way, we're going through here, right? So we did the maximum number of subnets that you can create, right? So we get 2 to the power 1, which is 2 subnets from our initial block. So we could get 2 subnets created. So that's the max number of subnets that we could create. Then for B, we needed the maximum number of hosts that can be addressed in each subnet, which we found here. So 2 to the power 7 minus 2, 126 hosts max. So that's the maximum number of hosts that we can address. And now we're going on to the new subnet mask. So to get the new subnet mask, we write the old subnet mask in binary first. So this is the subnet mask that we were assigned, basically, which was a /24. Remember here, our initial block was that, which is a /24. So a /24 means that you have 24 bits here. So you could either write out this, if you know, depends on how you know it. You could either write out this and write 24 ones, which you could see from the /24, and then convert it to decimal. Or if you have it memorized already, you know 255.255.255.0 is a /24. But if it's a weird address like a /27, you might know this off the bat. So the way to convert from the cider notation here into the decimal conversion would be to write out ones, as many ones as you have in the slash. So in this case is a /24, so we write out 24 ones, and then we convert this into decimal, which gives us 255.255.255.0. So that's just to get our initial subnet mask, right? That was the old subnet mask. So now to get our new subnet mask, we add our one borrowed bit to make the new subnet mask. So remember, we had 8 minus 7, which is 1 bit to subnet with. We borrow in 1 bit in these subnets. So we add in that 1 bit that we borrow in to make our new subnet mask. So we get all of these 24 ones plus 1 more, which gives us 255.255.255.128. So when we convert this to decimal, we get this, or we put a /25, because of course we borrowed 1 bit from 24, so we get 25 basically. And that answers this question, the subnet mask of each new subnet in both notations. Next, we need to get the network address and broadcast address of each new subnet. So that was just the question here, the network address and broadcast address of each new subnet. That's what Shiva wants to know. So we come here. The network address of the first subnet is always the same as the network address of the initial network or the initial block. So remember, this is the block we were assigned. So our first subnet address will be this exact same thing, except for this /24, of course. It'll be a /25 now. So our initial block was 170.246.165.0/24. This address portion is going to be the same as the network address of our first subnet as well. So the network address is just this, copied over from here, and converted to binary. So this is just the network address there. I believe in the lab they filled out the first one, but if they do have it, this is how you get it. Just copy across the address from the bigger block that we're subnetting from. That's always what we start with. Now to get the broadcast address of this first subnet, we set all of the host bits to be 1. So remember, we borrowed this bit here, so this is not a host portion anymore. We converted this into a network portion. So now our host bits in the subnet remains the last 7 bits here, which is what I highlighted in yellow here. So to get the broadcast address, we set all of these bits to be 1. So setting all the host bits to be 1 means that these things are just copied over here, and this 0 stays the same, but the yellow portion becomes 1. So put everything to be 1 in there. And converting this back into decimal gives us this. So this converted into decimal gives us this. This is the broadcast address for our first subnet. Yeah. So we had the network address for our first subnet, and now we have the broadcast address for our first subnet. Now to get the network address of our second subnet, we increment the borrowed portion of our initial network address by 1. So this borrowed bit that we had here, which I highlighted in green here, it was 0 for the first subnet, so we leave it as 0 for the first subnet. And just by the way, if we had borrowed more than 1 bit, for instance, if we had borrowed 2 bits here, we'd have left both of those borrowed bits to be 0. Same thing with 3, same thing with 4, however many borrowed bits. We leave those to be 0 for the first subnet then, and then for the second subnet, you just increment that by 1. So you add 1 to that borrowed portion. So you see the borrowed portion there, we increment it by 1, or we add 1 bit to it. So in this case, we just have that 1 0 there. So adding 1 to that makes the whole thing 1. So just get 1 there. So the network address of our second subnet is thus this whole thing with a 1 there instead of the 0, and we leave all the host bits to be 0. So what we're concerned about here is the borrowed bit. We add 1 to it, we get 1 here, and then we convert into decimal. And if we, in this case, we only have 2 subnets, right? Because we could only increment this once for 1 bit. If we had 2, we could have incremented it again and get our 3rd subnet, as we did in the example. So we could have added a 1 again, but in this case, we could only add 1 once. So yeah, so converting this into decimal gives us this, and to get the broadcast address of this first subnet, we set all the host bits to be 1, just as we did in the last subnet. So in this case, we have the borrowed bits as 1 here, and we're setting all of these to be 1 as well. So we're not touching this, we're incrementing this to get the network address, which is what we have here. And now to get the broadcast address, we set in all of the host bits to be 1, which gives us this in decimal. This is the broadcast address of our second subnet. So I hope you're following how we get the network address and then how we get the broadcast address. Now we have the network address and the broadcast address of all of our subnets. So that was the question that we had here, network address and broadcast address of each new subnet. And then, sorry, here. Now we need to get the first usable and the last usable address of each subnet. So to get the first usable address, we take the network address of each subnet and increment the host portion by 1 bit. So remember, we had the network address already. So for our first subnet, our network address was this thing, and converted into binary was this thing. Incrementing the host portion by 1 bit gives us this thing. So we're not touching the borrowed portion, we're incrementing the host portion by 1, which means we add in 1 bit. Well, we add in 1 to this. So 0 plus 1 is 1. Put the 1 there. And then you convert that into decimal, and this is our first usable address. So this is the first address that can actually be assigned to a printer or a PC or anything on the subnet. The first usable IP of this first subnet is thus this. For the second subnet, our network address was this. So this with the 1 there instead of the 0, which was this in decimal, and incrementing the host portion by 1. So same thing, adding 1 to the host portion there. 0 plus 1 gives us this. You see the 1, 0 plus 1 becomes 1 there. And then if we turn this into decimal, we get this. So you see it's the same thing as adding 128 plus 1 there, which is the first usable IP of the second subnet. So in the second subnet, we could this is the first address that we could assign to a printer or a machine or anything. To get the last usable IP of each subnet, we take the broadcast address of each subnet and subtract 1. So instead of adding 1, we're subtracting 1 to get the last usable IP. So for the first subnet, our broadcast address was this thing, with all of the host bits set to 1, which was this in decimal. So subtracting 1 from this gives us this thing minus. So you see the 1 there, 1 minus 1 gives us 0. So get the 0 there. Or in decimal, 127 minus 1 gives us 126, which is our last usable IP. For the second subnet, our broadcast address was this thing, which was that in decimal. Subtracting 1 from this broadcast address gives us 0. So 1 minus 1 gives us 0 there. So 170.246.165.254 is the last usable IP, which is the last address we can address, we could put on something in the subnet. So you can see we could do it in binary or we could do it in decimal. If you see this and you minus 1 from 255, you get 254. The reason I said to do it in binary is that you may not have it perfectly aligned with the dots here. Remember, this dot is just a kind of imaginary dot that we put in. If you have a weird subnet, like instead of a /24, if I give you a /22, you might have to borrow bits that kind of cross this dot here. And in those cases, it becomes very difficult to do it in decimal. So it's much easier to just do it in binary, and then this green portion just extends across here. No problem. Binary is binary, but in decimal it becomes a lot more difficult. With those kind of weird /20s or /21s or /22s or anything, once you have numbers that cross in this boundary in the octet. So that's why I said just stick to binary and keep it simple. And as you practice, you'll realize shortcuts as well. So you'll realize that for the most part, we didn't really need to convert this portion into binary, because we didn't really edit this portion that we didn't borrow, we didn't change in any way. So you'll see a lot of people write like 172.246.165 in this, and then they'll only convert the interesting octet into binary. So they would have literally wrote 170.246.165.1111111, and they would have only edited the bits here. So you'll get those little shortcuts as you practice, but I did it in the complete fashion just to help you all get off the ground. Yeah. And of course, let me close this. Of course, as you read these questions and as you understand what they're asking, and you get faster and faster with these questions, feel free to go on to here in the more advanced questions, where they'll give you some more advanced topics. They'll go on to VLSM, which is variable length subnet masks, and all of these weird questions. But build the basics first. Practice with these basic questions and make sure you understand this first. Yeah, so I hope you all understand now, and I hope this video was useful.